Can a volcano erupt and cause a global famine? It sounds like something from a movie, doesn't it? But it's a real question people have asked for a long time. The short answer is yes, it can happen. And it has happened before. It's a complicated chain of events, but the main idea is pretty simple to grasp. When a very large volcano erupts, it doesn't just shoot out lava and ash right near the crater. That's what we usually see in pictures or on the news, but some eruptions are much bigger. They blast huge amounts of material high up into the sky. We're talking miles and miles up past where planes fly, into a layer of the atmosphere called the stratosphere. So what kind of material goes up there? A mix of things. There's ash, of course. That's the stuff that makes the sky dark and can cover everything on the ground. But more important for global weather are certain gases. The big one to remember is sulfur dioxide. When this gas gets high up, it doesn't just float around, it changes. It reacts with water vapor and other chemicals already in the atmosphere. This creates tiny, tiny particles. These particles are called aerosols. They are basically a fine mist, like a haze, but super high up. Now, why does this matter? Because these aerosols don't just disappear quickly. They can stay up in the stratosphere for months, sometimes even a year or two, after a really big eruption. And while they're up there, they do something important. They block sunlight. Think of them like a giant, thin, reflective umbrella covering a good part of the Earth. When less sunlight reaches the Earth's surface, a few things happen. The most obvious one is that the temperature drops. The planet gets colder. It's not a huge drop, maybe just a degree or two on average globally, but that average hides bigger changes in certain places. Some regions might experience much colder weather than usual, and this cooling isn't just a gentle chill. It can lead to things like frost in summer or much heavier snowfalls in winter. But it's not just about temperature. The aerosols in the atmosphere can also mess with weather patterns. They can change how winds blow, where rain falls, and how big weather systems move around. For example, some studies suggest they can weaken monsoons, which are vital for farming in many parts of Asia. Or they might cause more rain in places that usually get less, and vice versa. So you have colder temperatures, strange rain patterns, and less direct sunlight. What does all of that mean for food? It means bad news for crops. Most crops need a certain amount of warmth, sunlight, and regular water to grow well. If summer suddenly gets cold, with frost in July, or if the rains don't come when they should, or if it rains too much, then the crops won't grow. They'll fail. When crops fail on a wide scale, there's less food. Less food means higher prices. People can't afford what little food there is, and if this happens over a large enough area, or in multiple important farming regions at the same time, then you have a serious problem. You can have food shortages. People go hungry. This is what a famine is. So the basic connection is clear. Big eruption puts stuff in the sky. Stuff blocks sun. Earth gets colder and weather changes. Crops fail. People starve. It's a scary thought, especially because volcanoes are a natural part of our planet. We can't stop them. But understanding how they affect us is the first step to thinking about what we can do. The history books actually tell us a powerful story about this very thing. There's one event that really stands out when we talk about a volcano causing global trouble. It's an important lesson from the past. It shows us just how vulnerable we can be to the power of nature. If you want to see a clear example of a volcano causing widespread misery, you have to look back to the early 1800s. Specifically to the year 1816, people called it the year without a summer. It was a truly strange and terrible year for many parts of the world. And the cause wasn't a mystery for long. Once people put the pieces together, it was a volcano thousands of miles away. The volcano was Mount Tambora. It's located on an island called Sumbawa in what is now Indonesia. In April of 1815, Tambora erupted. It wasn't just any eruption. It was one of the largest, if not the largest, volcanic eruptions in recorded human history. Imagine a mountain just exploding with unimaginable force. The sound of the explosion was heard over 1,000 miles away. Ash rained down over a huge area, plunging islands into darkness for days. The immediate effects were devastating for the people living nearby. Many died from the blast from ashfall and from tsunamis it triggered. It changed the landscape forever. But the real far-reaching impact of Tambora wasn't felt right away. It took time for the material it blasted into the atmosphere to spread around the globe. And as we talked about, it wasn't just ash that caused problems far away, it was the sulfur dioxide. Tambora sent an enormous amount of this gas high up into the stratosphere. Over the next few months, these sulfur aerosols circled the Earth. They formed that reflective haze, that global umbrella. By the summer of 1816, people in Europe and North America started to notice something was very wrong with the weather. It wasn't just a cool summer, it was bizarre. In May, many parts of the northeastern United States and Canada saw heavy snowfalls. In June, a widespread cold snap brought frost, killing crops that had just been planted. Farmers woke up to see their fields covered in white, not from dew, but from ice. This happened again and again through July and August. It was just unheard of. These are the months when crops are supposed to be growing fast, soaking up the sun and warmth. And it wasn't just cold, the weather was also incredibly wet and dark. Constant rain and gloomy skies were common. Their lakes and rivers froze over in places where they never had before in summer. The sun seemed weak, almost as if it were behind a permanent veil. This lack of sunshine and warmth meant that crops simply couldn't grow. The corn crops failed across New England and New York. Wheat and oat harvests were terrible in many places. In Europe, it was a similar story. Ireland, Scotland, France, Germany, and parts of Central Europe all reported incredibly poor harvests. The grain that did grow was often stunted, disease-ridden, or wouldn't ripen properly. The consequences were immediate and severe. Food prices skyrocketed. People who were already poor or just scraping by found themselves unable to buy food. This led to widespread famine. In Ireland, the potato crop failed, leading to starvation and disease. In Switzerland, thousands died from hunger. In France, the price of wheat doubled in a year. People ate whatever they could find. They ate weeds, cats, even bark from trees. There were reports of people being so desperate they ate rotting carcasses. This severe food shortage led to other problems. People became weak and susceptible to disease. Typhus and cholera spread easily among the starving population. Many tried to migrate, moving from rural areas to cities or from Europe to America, hoping to find food and work. But the cities were also struggling, and the new lands often couldn't support the influx of people. This caused social unrest. There were food riots in many cities across Europe. Governments struggled to cope with the crisis. The lack of food also fueled political instability in a period already dealing with the aftermath of the Napoleonic Wars. Even cultural impacts were noted. The gloomy, strange weather is said to have inspired writers and artists. Mary Shelley, stuck indoors in Switzerland during that cold, wet summer, wrote Frankenstein. Lord Byron penned a poem called Arkness, describing a world plunged into gloom. These were small echoes of a much bigger, more terrifying reality for millions. The eruption of Mount Tambora in 1815 undeniably caused a global cooling event in 1816 and 1817. This cooling, combined with the drastic changes in weather patterns, led directly to widespread crop failures. And those crop failures led to severe famine, disease, and social upheaval across vast parts of the Northern Hemisphere. It wasn't just a regional disaster, its effects were felt directly and indirectly on multiple continents. Tambora stands as the clearest and most devastating example of a volcano's eruption causing a global famine in recent history. It really drives home the power these natural events can have. Tambora in 1815 is the standout example, the one everyone points to. But were there other times volcanoes caused widespread hunger? And is it always so simple, a direct line from eruption to famine? The answer is it's often more complicated, but there are other instances we can look at. Let's consider another famous eruption, though not quite as globally impactful as Tambora. This was the Laki eruption in Iceland, which started in 1783 and continued for about 8 months into 1784. Laki was a fissure eruption, meaning lava poured out of a long crack in the ground, not from a single cone. It released an enormous amount of sulfur dioxide into the atmosphere. This eruption devastated Iceland itself. The Laki haze blanketed the island, killing livestock and crops. It led to a terrible famine where about a quarter of Iceland's population died. But Laki's effects spread beyond Iceland. The haze drifted over Europe. People reported strange reddish skies and a strong, unpleasant smell. Their temperatures dropped significantly across parts of Europe during the summer of 1783. This led to poor harvests, especially in France and Britain. The cold weather then persisted into a very harsh winter in 1783 to 1784. The River Thames in London froze over. Crops failed, animals died, and food prices rose sharply. There was widespread hunger and hardship. Many historians believe the economic distress and food shortages caused by Laki contributed to the social unrest that ultimately led to the French Revolution just a few years later. So Laki definitely caused famine, but was it global? Perhaps not in the same sense as Tambora. Its atmospheric effects seem more concentrated over Europe and parts of the Northern Hemisphere, not affecting Asia or the Americas in the same dramatic way. Still, it shows the power of sulfur emissions from a volcano to cause widespread suffering. Then there are much older events. We know about supervolcanoes like Toba and Sumatra, which erupted about 74,000 years ago. This was an eruption on an almost unimaginable scale. Scientists believe it plunged the Earth into a volcanic winter that lasted for years. Global temperatures would have dropped dramatically, perhaps by several degrees. This kind of event would have certainly devastated plant and animal life. Some theories even suggest it caused a human population bottleneck, meaning the human population shrank drastically, perhaps to just a few thousand individuals globally. If that's true, it means Toba led to a famine for our distant ancestors on a truly massive scale, threatening our very survival as a species. But linking it directly to the famine we understand today, with agricultural collapse, is harder because early humans were hunter-gatherers, not farmers. Still, the impact on food sources would have been immense. Another big one, still debated, happened in 536 AD. Historical records from around the world talk about a period of extreme cold, darkness, and crop failures. Accounts from Byzantium, China, and Ireland all describe a dry fog, a darkened sun, and severe weather that lasted for well over a year. The sky was dark enough that shadows were not cast at noon. This led to widespread hunger, disease, and social upheaval across Eurasia. For a long time, the cause was unknown, but recent ice core data suggests a massive volcanic eruption likely triggered it, possibly a volcano called Ilopango in El Salvador, or perhaps one in Iceland. Regardless of the exact volcano, the evidence strongly points to a volcanic eruption causing a severe and widespread climatic downturn that led to massive famines and hardship across much of the northern hemisphere. These examples show us that Tambora wasn't a one-off, but they also highlight something important: pre-existing conditions. A volcano might be the trigger, but it's rarely the only reason for a famine. Think about the world in 1816. Europe was just recovering from years of devastating Napoleonic wars. Economies were fragile. Governments were often unstable. Food distribution networks weren't as robust as they are today. Many people were already living on the edge of poverty. When the crops failed, there was no safety net. There were no global food reserves, no quick way to import food from unaffected regions. It's like a person who is already sick. A minor infection might be what pushes them over the edge, but they were vulnerable to begin with. In the same way, societies that are already struggling with poverty, conflict, poor infrastructure, or inefficient farming practices are much more vulnerable to a sudden shock like a volcanic eruption. The eruption acts as a powerful punch, but the existing weakness of the system determines how badly it gets knocked down. And the word global is important to consider. Even with Tambora, not every single place on Earth suffered a famine. Some regions might have been less affected, or even saw slightly different weather that was less damaging. But the interconnectedness of our world means that even regional famines can have ripple effects. Mass migrations, trade disruptions, and political instability can spread problems far beyond the directly affected areas. So while the immediate physical impact of a volcanic eruption might vary geographically, the human and societal consequences can spread far and wide. It's never a simple case, but a complex interaction of nature and human circumstances. We've talked about the events, the history. Now let's dig a bit deeper into the science of how a volcano changes the weather and leads to food problems. It's pretty clever how nature does it, even if the results are devastating. The most important part of a really big famine-causing eruption is not the lava. It's not even the ash, at least not the ash that causes global effects. The key player is a gas called sulfur dioxide, or SO2. And volcanoes release huge amounts of this gas when they erupt, but it has to be a powerful eruption. It has to blast this gas high up into the atmosphere. We're talking about the stratosphere, that layer roughly 10 to 50 kilometers, 6 to 30 miles above the Earth's surface. Why the stratosphere? Because the air up there is very stable. It doesn't have the same kind of weather and mixing that happens in the lower atmosphere, where rain washes things out quickly. So when sulfur dioxide reaches the stratosphere, it can stay there for a long time. Once it's up there, it goes through a chemical reaction. It combines with water vapor and other gases to form tiny droplets of sulfuric acid. These are incredibly small, microscopic particles. We call them sulfate aerosols. Imagine billions and billions of these tiny, shiny droplets floating high above the Earth. What do? They are very good at reflecting sunlight. When sunlight hits them, a good portion of it bounces right back into space. It never reaches the Earth's surface. Think of it like putting on a pair of sunglasses for the whole planet. Less sunlight means less energy reaching the ground, and less energy means less heat. This is why the Earth's surface cools down after a major volcanic eruption. The cooling isn't uniform. It's often more pronounced in certain areas, especially in the mid-latitudes where much of the world's agriculture takes place. We're talking about a global average temperature drop of perhaps 0.5 to 1.5 degrees Celsius, 1 to 3 degrees Fahrenheit for a year or two after a Tambora-sized event. That might not sound like much, but it's enough to cause big problems. Consider agriculture. Many staple crops like wheat, corn, and rice have specific growing seasons. They need a certain number of warm, sunny days to mature. A 1 or 2 degree drop in average temperature, especially during the summer months, can delay ripening, stunt growth, or even cause crops to die from frost. Frost in July, as happened in 1816, is a death sentence for most crops. But it's not just about simple cooling. These stratospheric aerosols also mess with atmospheric circulation patterns. They can change how major air currents flow. This can, in turn, affect precipitation patterns. For example, some studies suggest that large eruptions can shift the Intertropical Convergence Zone (ITCH), a band of low pressure that brings rainfall to tropical regions. If this band shifts, it can lead to drought in some areas like parts of Asia that rely on the monsoon and excessive rain in others. Both drought and too much rain are bad for crops. So a volcano's eruption doesn't just make the world a bit cooler. It makes the weather unpredictable and extreme. Farmers depend on predictable seasons. They know when to plant, when to expect rain, and when to harvest. When a volcano throws all that out of whack, it's very hard for them to succeed. How long do these effects last? The sulfate aerosols gradually fall out of the stratosphere. Most of them are gone within 1 to 3 years after a major eruption, so the effects are usually temporary, but those few years can be critical. One bad harvest might be manageable, 2 or 3 in a row or widespread across many regions, that's what leads to famine. It's important to differentiate between ash and these sulfate aerosols. Ash is heavy. It falls out of the sky relatively quickly, usually within days or weeks, depending on the eruption's height and wind patterns. Ashfall can bury crops, collapse buildings, and disrupt air travel. This causes severe local problems and can definitely cause regional famine. But ash doesn't stay in the stratosphere long enough or spread widely enough to cause global temperature drops and widespread weather changes in the same way that sulfur dioxide aerosols do. It's the persistent reflective veil of sulfuric acid droplets high up that has the global reach. Scientists study this using things like ice cores. When snow falls in places like Greenland or Antarctica, it traps bits of the atmosphere from that time. By drilling down into the ice, scientists can find layers with high levels of sulfate, which indicates a major volcanic eruption occurred. They can even date these layers quite precisely, helping us link past eruptions to historical records of climate and famine. So the science is clear. A powerful volcanic eruption, especially one rich in sulfur, can inject massive amounts of sulfur dioxide into the stratosphere. This forms a reflective aerosol layer that cools the planet's surface and disrupts global weather patterns for a few years. These climatic changes, in turn, can devastate agriculture across wide regions, leading directly to food shortages and famine. It's a powerful and effective mechanism that shows just how connected our planet's systems are. So, we know volcanoes can cause global famines. Tambora showed us that. The science explains why. But what about today? Could it happen again? And if it did, would we be any better off? These are important questions to think about. Yes, a Tambora-sized eruption could absolutely happen again. There are still many active volcanoes around the world capable of such a blast. We can't predict exactly when or where the next one will be, but it's a certainty that one will occur eventually. The Earth is a dynamic planet. It's always been this way. If a major sulfur-rich eruption happened today, say a VEI 7 volcanic explosivity index 7, like Tambora, or even a VEI 8, a supervolcano eruption, the initial physical effects would be similar. Sulfur dioxide would shoot into the stratosphere, sulfate aerosols would form, the planet would cool, and weather patterns would shift. We would likely see crop failures in many key agricultural regions, just like in 1816. But how would modern society cope? We have some advantages compared to the early 19th century. Our global food system is incredibly interconnected. We can transport food around the world much faster and more efficiently. We have global markets and commodity exchanges. Many countries have strategic food reserves. We also have advanced farming technologies, including irrigation, genetically modified crops, and weather forecasting, which might help mitigate some damage. We monitor volcanoes much better now. Scientists have a good idea of which volcanoes are dangerous and are constantly watching them for signs of activity. However, we also have new vulnerabilities. Our global food system, while interconnected, is also incredibly complex and often operates on a just-in-time basis. This means there isn't always a huge surplus sitting around. Supply chains are long and can be easily disrupted. On a major hit to food production in several key breadbasket regions like the US Midwest, parts of Europe, or Russia would quickly cascade through the system. If enough major food producing nations experience simultaneous crop failures due to volcanic cooling, then global food prices would skyrocket and widespread shortages would quickly follow. Consider the sheer number of people on Earth today. In 1816, the global population was less than a billion. Well, today, it's over 8 billion. Feeding that many people requires massive, consistent agricultural output. A sudden multi-year drop in food production would be catastrophic, even with our modern technology. We might avoid a complete collapse into eating tree bark, but severe widespread hunger, malnutrition, and disease would be almost inevitable for hundreds of millions, if not billions, of people. The impact would also be very uneven. Wealthy nations with strong economies and stable governments would be better able to buy up what food is available, distribute it, and manage the crisis. But poorer nations, especially those that are already food insecure or rely heavily on imports, would suffer immensely. They would be outbid for food, their economies would collapse, and their populations would face starvation and widespread social unrest. The humanitarian crisis would be on an unimaginable scale. So, while we might be more resilient in some ways, our increased population and reliance on a globalized, complex food system also make us incredibly vulnerable to a major external shock like a volcanic winter. It's a delicate balance. What can we do? Preparedness is key. 9-1. Monitoring scientists continue to monitor potentially dangerous volcanoes worldwide. Your early warning, even if it's just a few months or a year, could be critical for planning. The threat of a volcanic eruption causing a global famine is not just a historical curiosity. It's a real, ongoing risk that our modern world still faces. We've learned a lot from past events like Tambora. We understand the science much better now, but the sheer scale of the potential disruption, combined with our growing global population, means that future volcanic winters could pose an even greater challenge to humanity. It's a powerful reminder that even with all our progress, we are still very much at the mercy of the planet's powerful natural forces.